No, it's not going.
उसको मिनिमाइज कर देना है.
हाँ मिनिमाइज करेगा.
हाँ वो अच्छा रहेगा. वो फिर बैकग्राउंड में रहेगा, नहीं तो कनेक्शन में प्रॉब्लम हो जाएगा.
अरे अरे. I don't know what to do now. Okay, I'll call my consultant. Okay. Meanwhile, you can draw this picture.
Mhm.
1 minute. Yeah, you have got that percentage of complaints and cumulative. Now, which one do you think we should plot? Percentage of complaint or cumulative percentage of complaint?
Percentage of complaint.
Percentage of complaints.
Sir, there is a little problem I have faced. Could you come here for a minute? थोड़ा एक प्रॉब्लम आ गया, कौन दूसरा कुछ आ गया. So can you help me out? Just. हाँ काम चल रहा है. So 1-2 मिनट के लिए आइए साहब. Sorry. Okay. Yeah. Which one do you part? You said that percentage of complaint.
Percentage of complaint, yes.
Any other view?
That is on the x-axis reason, and then on the y-axis percentage.
X-axis what? Which one?
The reason for complaint, and the y-axis percentage of complaints of that.
Any other view?
That.
Any other view? Any other view?
No, sir. I feel I also will go for percentage of complaints only.
Any other view? I'm asking. Then why did you calculate cumulative percentage of complaints? Okay. I have got out of it now. Okay, sorry. Then I'll tell you. Okay, let's go ahead and this one. Now, I think we should stop. I mean, we should plot both. You know, why did you calculate cumulative percentage? You have to calculate both. You know, you have to plot both.
Okay.
So, you see here, x-axis, as you have rightly pointed out, reason of customer complaint.
Yes, sir.
And y-axis, sorry, I sometimes this one is not coming, you know, with this. It's getting stuck. It's normal. See, I am preferring this one. Sometimes it doesn't come. One big slide came, then I press this one, something else come out. Okay. So I'm sorry. I was trying to get you. Yeah, it's okay now. Try to contact you. Sorry. Okay. Thank you, sir. 1 minute, sir. Why this line came from where? This line now is earlier. This line is not there. All the lines are coming there. Okay, sir. Yeah. Sure. Okay. Thank you, sir. Okay, now let's plot this and see. Your x-axis, if you can manage, you don't give gap. You know, I could not make it overlapping. So you try to make it overlap, you know, one after the other, not separate it out. As you have rightly pointed out, reason of customer complaint.
X-axis.
X-axis, y-axis, individual. This bar diagram will give you individual, and that line diagram gives you cumulative.
Okay.
Okay, line diagram gives you cumulative. Okay, for example, now what is the conclusion? This is Arihan Pareto analysis on customer complaints, double swing, period difference, so and so, prioritization is the idea, source of data, and so on. Now, graph is drawn. What is the conclusion? Any of you can help me in drawing the conclusion?
The highest customer complaint is from belt seat on, and as we move shift towards the right, at a particular point, you will see the, some like break even or more than 50%, which has contributed more than 50%.
Any other person who can help me in interpreting? Kavita? Shamir? Any of you can help in concluding? Go ahead.
Here it says that out of 100%, 74% is contributed to the first three.
Right, that is one thing. Out of how many complaints?
Out of कोई ना सर आपने पीछे साइड में बताया था कुछ 30 complaint या
30.
Out of how many complaints?
30 complaints.
30 complaints.
How
No,
many?
30 reasons were there.
Yeah, that is the starting point. Quite often people mistake it by telling the 8 number of complaints is 8, which is not the case, you see. That is,
It's 30
Yes.
complaints.
yes, that is the start.
8 reasons.
Conclusion, out of 30 reasons of customer complaints, only 3, namely belt seat torn, bearing damaged, and rivet broken, contribute to nearly 3/4. That is 74.4% to be exact of the total number of complaints on double swing during so and so period. Is it clear now?
Yeah,
This
which means if I put it this way, the cumulative now has given this data.
Yes. So cumulative has given this data. Now, what is the meaning of this is that you as a boss should concentrate only these 3 reasons. Okay? Your assistants can look after the 23 other 23. You don't fritter away your energy by running into 30 complaints and all that. Okay? So prioritization takes place in this. Can you give example in your industry or in your work area where you can apply this? There's a tremendous application potential. Where can you apply this?
Yes, it is possible, sir. We can apply this in various like rejection. How much? What is the source of rejection? What are the breakup of
Reasons of rejection? Yeah.
Yeah,
Then,
exactly. Yeah.
what else?
In recruitment based on degree, like engineering, separate,
Yes,
law, that also we can do. So we'll have the CEO will get an idea as to what is the trend of appointment of various people based on their specialization.
Yes. Anybody else can help me in their application situation of Pareto? Anybody from in your
I think,
yeah, please.
yes. Even I think that in teaching, I can apply this because especially when we are dealing with, students enrolling for a course. So sometimes they quit or they go for other more lucrative courses. So here
Yes.
probably I can figure out what is the, what are the causes why people are going for other courses.
Good
and why
idea,
not
good
this.
idea,
Something
yes.
like that I could apply and analyze.
Even the reasons of
The reasons.
reasons of your low placement, see, you can analyze that. Find out low average salary drawn during the interviews. Reason for a low percentage of people going into the such grades, you see. So,
Right.
and then rejection, rework, then customer complaints, absenteeism, market share, okay. You can sales, downtime, accidents, absenteeism, you can apply in large inventory management. You see, 70% of the inventory by number is hardly 20% of the 20% by value, as you know. Similarly, 20% of by number is hardly 10% by value. So that way you can have ABC analysis, what you do, you can apply that. So this has a tremendous application potential. It's Pareto analysis, which is very useful for that sort of thing. Okay. So therefore, this you must understand. Only one caution, we'll now go through this. You see, this Pareto analysis after studying the pattern of variation. The pattern of variation. Pareto analysis. After studying the pattern of variation. Okay. Now you see, this one is a rejection in a ferrous foundry. Identification of sporadic and chronic problems. Pitfalls in Pareto analysis. Pitfalls in Pareto analysis. You know, data on rejection in a ferrous foundry. Date and shift. First A shift, B shift, second A shift, B shift, and all that. Total production, so many numbers. Total rejection, so many numbers. Major reasons of rejection. Misrun, day-wise it is given. Sand drop, given day-wise. Sand wash, scab, blowhole, and others. Total number of rejection percentages. Now, if you do a Pareto analysis just on the basis of that, the percentage explained on which will be the highest sand drop, 36.5. Then it will come misrun 29.8. Then will come blowhole 18.0. But what is the peculiarity of the data you see? Can you study the data and tell me what is the peculiarity you are noticing here? Any of you can study this data and tell me the peculiarity? Any response, doctors and others? What is the study the data, study this pattern of these rejections, then tell me what is the peculiarity, particular observations you make out of this.
It gives what is the percentage of sporadic versus chronic.
Yes, which is sporadic you find here?
There is misrun and sand drop.
Ah, very good. Thank you, doc. You see there, out of misrun, you see it is coming 215, suddenly 113 one shift.
Yes.
Second B shift.
Yes.
Similarly, you see this one, sand drop, suddenly one shift, again B shift, you see 147. These
Yes.
are known as sporadic problems. Suddenly
Correct.
something happened and it
Yeah.
happened. Whereas blowhole, you see, it's a chronic problem. Every day it is happening.
Every day it's happening.
9, 8 and all that. So in such cases, you have to omit this sporadic data, sporadic problems, you have to omit,
And focus on the chronic ones.
focus on the chronic. Okay.
So that the system can be streamlined effectively.
Right. Because this will not happen every time. It will happen once in a blue moon and go away. You can ask the concerned supervisors, the supervisors of B shift, you ask them, what happened? What did you do on that day? What happened exactly? He'll be able to give you some answer in which you can sort out. A short-term solution can be found out. A long-term solution can be seen by applying a cross-functional team. You have to work it out and then accordingly work out this one. Okay. Cross-functional team, you should work it out on all that. Okay. So this is how we try to. Misrun and sand drop is a sporadic problem and blowhole is a chronic problem. Okay. So therefore, this is a pitfalls in Pareto analysis to try to figure out that. Okay.
Yes.
Shall we move on? Now you are clear of Pareto analysis and their applications?
Yes, sir.
Purpose is clear?
Yes, sure.
Okay. So now we can focus on certain major reasons. Like in the earlier case, we saw what major reason was, say, 3, namely belt stick tone, bearing damage, and defect. Now, say one by one, we tackle them and go through what is known as cause and effect analysis. Okay, so we'll go into cause and effect analysis. Yeah. This is known as a fishbone diagram or Ishikawa diagram, or also known as cause and effect analysis. cause and effect analysis. Okay. For example, let us take the example of cooking delicious rice. What are the major ingredients you take? One is raw material, that is the rice. It can have a grain size, tukra, and this one, raw or boiled source like Dehradun rice, and all that. Then it can have pre-treatment, addition of seasoning materials, soaking in lukewarm water, soaked in cold water, and all that. Then equipment is mud pot or stainless steel vessels or copper vessels. Heat treatment can be electric heater, coal use, coke use, firewood use, solar heater, cooker, and all that. You see? Similarly, a customer complaint comes. It can be quality problem, it can be service problem, it can be price problem, it can be this one. So many ideas come up of this one. Say a large percentage of failure in an institute. It can be due to the poor input intake of students. It can be faculty teaching, it can be infrastructure not right. It can be this one. There's so many reasons can come up with this particular idea. Okay, so therefore now you have to go into these details. The problem comes, after some time. This was discovered by Dr. Kaoru Ishikawa, who was a Japanese. He solved a lot of problems in railways and this sort of thing by using this sort of diagram. But then people later found out that how do you know which is more important in this? Okay. Because nobody is telling you. Now let's take a simple example to demonstrate as to what I'm talking about. I want the 5 volunteers and then tell me, let us take the 4 factors only. The rice, then pre-treatment, right, the raw material, pre-treatment, then heat treatment, and then equipment. I want 5 volunteers to tell me the weightages. What will you give to these 4 factors? So the total is 100. Don't give 25, 25, 25 and all that. That means now, Dr. Subramaniam, let me start with this. Tell me what is the weightages. Doctor.
First is rice will be about 70%.
Okay.
And then water 10%.
Okay.
Then heat 10% and seasoning 10%.
Okay, thank you. Yeah, Dr. Kavita. Now let us see what are your impart. How is your husband appreciating your cooking? Yeah.
I would say that 60% would be the rice, the quality and everything.
Okay.
I would give 10% to the pre-treatment.
Okay.
Whether it is soap, wash nicely and all that.
Okay. Okay.
I would give 15% to the treatment.
Okay.
Heat treatment.
Yeah.
And of course the kind of cooker and everything. So another 10% to the equipment.
The total should be 100, now, so another 15%.
15% equipment.
Okay,
Yes.
that is the 100 again. Any third volunteer? Another volunteer I need. 4 or 5 volunteers I need. Next. Please go ahead. Go ahead, another volunteer come. Weightages you give. Who else is there? Samir or anybody? Array, no voice is coming. Come. Some others also tell me. How many are?
I think they had a very heavy lunch and they have fallen asleep, I think.
Looks like. Yeah. You let us cook somebody else, whoever can give me some weightages. How much will you give for rice and then pre-treatment, heat treatment, and the equipment? Give me another volunteer, please. क्या हो गया? How many of you are attending now after lunch? Let me see number of participants. 9 are there. 9 participants has been there.
Hello, sir. Hello.
Yeah, please go ahead. How much weightages are
I'll
you
give
giving? Yeah.
I'll give you 60% of rice
Okay.
and 20% water.
Okay. Pre-treatment.
Yes.
And then,
And 10% equipment.
okay. 30, 50, 80 and
And
20%
another
20% on heat treatment. Okay. You are
yes.
you are Miss. What is your name?
Rema Raman.
Oh, Rema Raman. Okay, Rema.
Rema.
Yeah, Rema. Another volunteer. Another volunteer, please. I want a 4th volunteer. 5 people I need so that I'll demonstrate what I'm talking. Rema, you can coax somebody else to give us this. Yeah, come over. Go ahead. Whoever is talking.
Whoever can make khichdi can contribute, please.
Correct. Go ahead. Yeah. Yes. Rema, if your organization, you got some more.
Pardon, sir?
Some more is there now. Ask them to give. Ask 1 or 2 more to give me.
Yes. I am telling.
Yeah, please.
Give na.
Yeah, go ahead.
मैंने 60
Yeah.
Give na. Give na. Ah, yes.
Hello.
Yeah, please.
Sir, one more.
Yeah.
Yes. One more person.
Give me that. Give me.
Material 80%.
How much?
Raw material 80%.
Raw material? How much?
80.
Raw material, how much? 80.
Soup in cold water 20.
नहीं, first of all, rice raw material बताइए कितना बताया?
80.
80, okay, 80 and then?
Soup in cold water 20.
80 pre-treatment? Pre-treatment कितना?
Pre-treatment soak in water yes.
कितना?
नहीं सोकिन प्री-ट्रीटमेंट में तो सोकिन वाटर वो सेम ही है ना
वाटर चाहिए
हाँ आप तो एक्चुअली ज्यादा बोल दिया था
कितना? वो 80 है तो राइस हो गया उसके बाद pre-treatment, heat treatment and this one? बताओ?
heat treatment yes sir pre-treatment कितना है
Pre-treatment
कितना?
हाँ सर
क्या?
हाँ बोलिए ना
बताओ?
raw material 50%.
Raw material 50%, not 80. Somebody gave 80.
हाँ.
Then it can be 50.
So
okay.
cold water. हाँ.
Okay, how
Treatment
much?
30
No, total have to be 100, na?
total 100.
What are they? Now these four factors you give me?
बोलो ना
50% raw material, 30%
pre-treatment
pre-treatment,
Okay.
15% heat treatment, 5% equipment.
Okay.
चारों people different बोल दिए
नहीं वो उनको डालेंगे ना ये
हाँ then average
cooking का
डालते हैं ना
decision, क्योंकि राइस उससे भी कम चाहिए, ये तो 50-50 चाहिए.
नहीं सर, वैसा नाही ना.
नाही मॅडम, हे जे आहे ना, हे तर हे 50-50% मध्ये जाते आणि हे 5% मध्ये आहे. तरच हा
So,
हा,
110
तरच
आहे ना
तर
सर.
Finally we give one more, fifth one. With that we'll close.
Okay, one more. You give ना.
Yeah, one more.
Okay. नहीं, आपका कंप्लीट नहीं हुआ था.
Yeah, बताइए one more.
कीजिए ना.
Rice sir, 80%.
Okay,
So we need cold water 10.
10. Okay. Then heat treatment and equipment 5 is it?
Yes.
So that will become
Equipment
5 and heat treatment 5. So 100. Okay. Now let's see what is the variation you are getting. You see here, rice, the variation is coming from 50 to 80. Then pre-treatment, the variation is coming from 10 to 30, 1:3. Then heat treatment, the variation is coming from 5 to 15, 1:3. Then equipment, the variation is coming from 5 to 20, 1:4. What does it mean? What does it mean? None of them are expert in cooking rice, like me. You see? That is the problem. Same thing happens in industry, you know. Quite often we go for brainstorming session and you catch hold of people who have no idea of the problem at all. वो बड़ा पाव के लिए आ गया, चाय नाश्ता के लिए आ गया मीटिंग में, वो बोलता नहीं कब होगा, कैसा होगा, क्या चलता है, whatever comes to his mind he utters and goes away. So this is not the way to find the root cause, you know. The root cause has to be found out properly by using this. Okay, so therefore, this is the drawback of Ishikawa diagram. So this is taken care of. Why analysis is taken care of by, I'll tell you how this is taken care of, why verify why analysis. And similarly, for the brainstorming is taken care of. Brainstorming session, which is used for your cause and effect analysis, is taken care of nominal group technique or NGT. Okay, this is how I used to do that in earlier 70s. I told you. After my visit to Japan, I was telling you I was sent to Japan to understand Japanese way of solving root causes. You know, so this is very, very important from this sort of thing. So we had to have this one. Now you saw the problem: 4 people giving, 5 people giving, totally different sort of weightages on each one of them. So same thing. If you want to quantify that, which is the more logical and priority reason, it will have problem like this. So how do you go about? We have to understand that slightly later. Okay. So therefore, what is the purpose of Ishikawa diagram? Is cause and effect analysis. On what? On prioritized reasons for from the Pareto analysis. Okay. So that is the sort of thing what we have. Here also same thing happens. The 5 people were Mr. A, Mrs. B, Miss C, Mr. D. They gave the weightages and their averages is there. And we saw the variation as usual. Now, one of the reasons of finding root cause is why analysis. You know, this was taught to us. And when we came back to India after my training, there was a problem from customer complaints on the heavy rejection from during filling due to dent. This is the dome. This is the top portion is the cap. The bottom portion is the body. This is wall thickness and this one. You know, my boss was asking, now that you are trained, can you tell me how to go about this one? I said, no problem. We'll go for why analysis of that. You know, customer complained on excessive weight variation of capsules. Then boss was accompanying me. I asked them why. Hey, too much of fluctuation in viscosity of the bath. Then we said why? Because excessive variation in temperature. Then again, the question was asked, why? Malfunctioning of Apple panel, you know, the electrical panel which was procured from this one abroad. Then why? Poor quality of thermocouples. Then the boss was there, you know, he pointed out, look, these thermocouples were imported from Japan just last week. Then the fellow says, I don't know, because if he opens his mouth, then he will be out of the gate, you know. So this is what happened. In fact, I could not sleep for a couple of days because he says we spent so much of money on you and wasted money, and you never understood what is the actual, how to go about in solving this problem, you know. So I didn't know what to do, just went on thinking about it. And then finally, you know what we did is, one thing I came to my mind is this. Why verify why analysis? You know? Why verify why analysis? This is why analysis. Then we went and told you about why verify why analysis. Because the two machines are running with a more or less similar temperature. One of them has having problem, the other one does not have the problem. Then temperature in that range is not the problem. Same way, if two machines are running with a similar viscosity, one of them has a problem, the other does not have a problem, then viscosity in that range is not the problem. So we had to go to why. Every time you calculate, you find out the reason. What you are talking, verify with facts, you know. Fact-based data collection is important in all statistical analysis of that. Remember that. So why verify why analysis is what you have to do. Okay, clear? Now, a lot of examples you can say the cylinder does not operate smoothly. This is taken from the Japanese working in Hindustan Lever. The question is, what is your final action? The cleaning the strainer. After cleaning the strainer, is it okay? Yes, that means Kaizen gets closed. Now, why verify, why answer starts. Why did you clean strainer? Strainer was clogged. What did you do? Clean strainer. Why strainer was getting clogged? Oil was dirty. Dirty oil and was cleaned was the action. Why oil was dirty? Dart entered the tank. Then what did you do? Prevent scaling of chips and cutting fluid going inside. Why does dirt gets in? Because upper plate has hole in the and gap. What do you do? Plug hole and gap. Why was hole made? Repair error during this sort of thing, you know, repairing work. So standardized repairs. So that is how why analysis goes about, and act on that. I'll take another example from, again, Japanese worked out in Hindustan Unilever. You will find it more interesting. The question was, the problem was oil leaks from cylinder rod each time it operates. Mute yourself, please. Mute yourself. Please mute yourself. Question is, what is your final action? And replacing the O-ring. After replacing the O-ring, is it okay? Yes, that means the Kaizen gets closed. Why did you repair the O-ring? O-ring was getting cut. What is the action? O-ring changed. Why O-ring was getting cut? Rod had scratch. What did you do? Scratch removed. Why rod had scratch? Chips were scattered and getting attached to the rod. Why was it happening? Chips are getting scattered because it was not in the scattering distance. So what they made it, they changed the layout, and accordingly the problem was solved. Now you know this is the sort of thing which we have.
पासवर्ड नहीं भेजा तुमने भाई, तुम्हारा काम कर दिया मैंने और उसके बावजूद भी नहीं भेजा। ये सब उसका काम थोड़ी सुब्रा करता है।
Somebody is, I think.
वो करेगा क्या ऐसा काम?
Any problem?
नहीं मैं रूम पे हूँ रे, मैं आज 1 बजे बाद रूम पे हूँ। वो लेक्चर मेरे उस पे आ नहीं रहा था, तो मैंने फिर पर्सनल पे आ रहा है।
Any,
पर्सनल पे आ रहा
can we,
है। बहुत क्या हो रहा है बाकी?
can we
तुम नहीं हो?
move? Can we move?
तुम
Or
नहीं
you
हो
are,
क्या मीटिंग में?
you are discussing something?
Sir, we can move, no problem, we can move.
Oh, okay. Now let's talk about a simple technique known as acceptance sampling plans, which we have talked about that why, how much to sample and how to sample. This was why, that is the necessity. Why did you do the sampling? How, that is the methodology, and where, that is the application situations. Okay, so this is how we go about. Now, 100% inspection is, first of all, costly, then time consuming, holds up production, delays delivery, infeasible for destructive tests, and never ever 100% effective. You see? So this is the problem with 100% inspection. And many of them, it is infeasible. Like I told you, give you example, busting strength of paper, tensile strength of castings, opening torque of closure, okay? Life of bulb is infeasible for destructive tests, you see? It's very costly, 100% inspection cannot be done, for a mass production particularly. Time consuming, holds up production, delays delivery, infeasible for destructive tests, never ever 100% effective, okay? So this is the necessity of going for sampling plans. Where to apply them is applicable to incoming materials evaluation, in-process controls, pre-shipment audits, and scientific investigation of customer complaints. So this is equally applicable to number of places like that, okay? Now, so we have understood why should go about that. We have seen the vast application potential. Therefore, we now go for where, how to go about it, how, that the methodology. To understand methodology of acceptance sampling plan, we have to comprehend certain concepts and terminology first. Let's go through that. Now, product audit or acceptance sampling plan, concepts and terminology. We talk about lot. Lot means all the items coming in a lorry or all the things coming in a wagon. Okay. Lot size is the number of items in the lot. Lot quality is the proportion of defectives in the lot. We normally talk about AQL, that is acceptable quality level, that is P1. For example, it can be 1%. Up to 1%, you will accept that. Beyond that, you will reject. RQL is rejectable quality level. This you can note down. You know, this will not get you have RQL or rejectable. Earlier books used to call it LTPD, lot tolerance percent defective, 2%. Say 3%. Matlab, beyond 3%, you will definitely reject. Up to 1%, you will definitely accept. Between 1 and 3, you will just maybe you'll go for double sampling or go for sorting, call him and tell him and all that. So we'll do that. Now, producer's risk. Every sampling will have some risk. Generally taken as 5%, producer's risk. Consumer's risk is taken as 10%. The producer's risk is the chance of rejecting a good lot. Consumer's risk is chance of accepting a bad lot. You see? Normally, we categorize the defects into critical, which is functional. For example, a container, it can be leakage. Major, it may be a scratch. Minor, it can be slight shade variation. Okay. Level of inspection. Earlier, there are 5 levels. Now they have increased to ISO has increased to 7 levels. Titan, level 3. normal level 2, reduced normal level 1, and specially reduced S4, S3, S2, S1. We shall see them. Types of sampling plans: double sampling, single sampling, multiple sampling, and all. Then acceptance rejections or AQL plans, acceptance rectification, because you reject some lot in your house, in-house, then try to sort them out and send the good ones. That is average outgoing quality limit plans, AOQL plans. That gives more protection to consumers. AQL plans gives more protection to the manufacturers. You have noted down, write down first. This concept will be very useful for you. Write down first and then tell me, yes, you have copied, written. Because this is not systematically given in the book. As soon as you complete writing, you just tell me.
Sir, copy everything, all these points?
These points, particularly
Okay. Sure, okay.
this slide, do that.
Actually, we need more explanation on these levels of inspection, sir.
Yeah, we'll do it. We'll work out. The number of examples will work out. In the ratio wise, if you take 1:2.5 into 3 and 3/4, the reduced sampling you give 100, normal you will give about 250, and tightened level you will have 375. You know?
Okay.
Sample size will be very much more.
RQL stands for rejection quality limit.
Rejectable quality.
Okay.
Acceptable quality limit, rejectable quality.
And rejectable, okay.
LTPD lot tolerance percent defective.
Okay.
This
Sir,
was earlier-
3% थोड़ा ज्यादा हो गया ना सर? नहीं.
This was it's just an example. This is an example.
Okay. ठीक है sir, okay.
This is an example we have given. It can,
Okay.
it can be less. It can be less. This is why for minor defect to start with, which will tighten slowly year after year.
Okay.
Yeah. Santosh, are you there? Santosh?
Excuse me, sir.
Yeah.
RQL, it is rejected quality limit
Limit, yes.
Rejectable
or
quality.
Rejectable quality limit.
limit. Okay.
Level.
Limit. Okay.
Level, sorry, level. Tightened is actually stringent, na sir?
Haji?
जो
Tightened, yeah.
tightened it is stringent, right?
Yeah, very strict. Yeah,
Yeah.
quite strict. Yes, you are
Like
right.
pharma के लिए.
Yeah. Sarma, and where you are taking life-saving drugs and all that.
Yes.
Or aeronautics, space.
Yeah.
Space.
Hello.
Sir, LTPD. What is
LTPD
it?
yeah, what is
Tolerance percent defective. Lot tolerance percent
Low
defective.
lot
tolerance.
tolerance percent
It is the difference between the higher and the lower range.
percent.
Earlier books used to call them LTPD. Now they call it RQL, rejectable quality.
Sir, we are through, sir. लिख दिया हम, हो गया.
Oh yeah?
हाँ sir.
Okay. Now we go to
ये बुक में नहीं है ना. तो वही बोलते हैं
स्क्रीनशॉट निकाल दो ना.
निकाला सर.
हमने निकाला दोपहर
बट उसमें भी
सर OC कर्व क्या होता है? बनर्जी साहब. हेलो.
Yeah, yes, Doctor.
Sir, OC curve.
Operating characteristic curve.
Okay.
Operating characteristic curve.
Operating
OC curve. Operating characteristics. We shall do that. Now, so
Okay.
shall we move on?
Yes, sir.
All of you are ready? Right. Yeah, this is operating characteristic curve, typical OC curve.
Okay.
X-axis give you lot quality P, that is proportion of defective in the lot. Y-axis gives you the chance of acceptance of the lot, that is LP, level of probability. Probability, chance of acceptance of the lot. You say X, 0 means there will be 100% acceptance. And then producer's risk we normally denote by alpha. That is taken as 5%, you see. And consumer's risk is taken generally denoted by beta, and that is taken as 10%, you see. So ideally, the OC curve will be 1 acceptance, chance of acceptance is 1 up to AQL and 0 after AQL. But then a typical, it doesn't happen that way. A typical OC curve is shown this way. That is, this is the chance of acceptance, this the chance of rejection of a good lot. Up to this is a good lot, no? Up to PO and AQL is all good lots. This is the chance of rejection of a good lot, chance of rejection of a good lot, chance of rejection of a good lot. This is the maximum chance of rejection of a good lot, which is producer's risk 1 minus LP1. That is 5%. So therefore, this is chance of acceptance is 95%. Now let us say consumer's risk. This is a chance of acceptance of a good bad lot. Acceptance of this is a maximum chance of acceptance of this one. So this is taken as consumer's risk or LP2, rejectable quality. Beyond that, everything is bad. There is chance of rejection of a acceptance of bad lot, acceptance of a bad lot. There is a maximum chance of acceptance of a bad lot, that is taken, defective lot, that is taken as 10%. So this is a typical OC curve. Every sampling plan will have a OC curve, which will give you 0 means 0% defective, 100% acceptance, 100% defective means 0% acceptance. In between, this is what happens. Okay. So this becomes steeper and steeper when you go for reduced to normal, normal to tightened and all that. So that is how it operates. Okay. Therefore, this is not what it is. Okay. Now let's take an example. Now you open your book. Open your book. Now this book will be very useful for you. Sampling plans tables.
Page number.
What's the page number, sir?
I'll give you page number. That's what I am opening. Yes. Page number 30-52. 30-52. 30-52.
Lot size लिया.
Got it?
Yes.
All of you got 30-52?
Yes, sir.
ST3, that is sample size code letter, is we call it SSL, by lot size and inspection levels of ISO 2859 part 1. This ISO has brought it out. Earlier, ISI had 5 levels of inspection. ISO has brought it out 7 levels of inspection. Now here you see what is the lot size? 1,47,000. And if you go for normal level of inspection, what is the sample size code letter? 1,47,000 comes between 1 lakh to 3,50,000. Na?
कौन सा sir? Which one I said? Sorry.
1,50,000.
Table number ST3.
3. Okay. Sample size code letters.
Sample size code letter, let's find out where does 1,47,000 comes.
1,47,000.
Between 35,001 to 1,50,000. Between 35,001 to 1,50,000.
Yes, sir.
And suppose we go for normal level of inspection. What is the sample size code letter?
N लिखा है.
Right, N.
N.
For
N.
Nagpur. N for Nagpur. All of you are clear?
Yes, sir.
Right, this is what is given here. You see?
Yeah.
From sampling plan table ST3, sample size code letter SSL corresponding to a lot size of N is 1,47,000, falling between 35,001 and 1,50,000. And level 2, normal level of inspection is N. N. Okay? Are you able to read this?
And this is
Now go for next table, ST4. Go to ST4. See N. Corresponding to N, suppose
500.
AQL of 1% is selected. AQL of N, AQL of 1%.
500.
What is the acceptance number? AQL of 1%. Go for 1% AQL. What is the acceptance number?
1.
Or
10 and 11, sir. 10,
Right.
10.
11.
10.
10 is the
11.
acceptance number and 1
10, 11.
11 is the rejection number. Okay. So this is what he's talking next sentence. Now from statistical table ST4, single sampling AQL plan with SSL equal to N, the sample size N equal to 500, the sample size N equal to 500 and acceptance number and corresponding to 1% AQL, the acceptance number A equal to 10
10.
and
Yeah.
rejection number
Is
R
11.
11. Okay.
Yes.
One more than the acceptance number because it's a discrete circle. What does it mean? This implies that from a lot of 1,47,000 items, we have to draw a sample of size 500 and inspect them for all attributes defects. If the number of defectives are 0, 1, 2, up to 10, accept the lot, otherwise reject them. Okay?
Mhm.
Is it clear now?
10
Yes, sir.
can accept them.
Read this,
We
read this, read this and see if you have to.
Yeah, sir. Where will we get this defectives 0, 1, and 2?
No, you inspect them and find
Okay,
out
after inspection. After inspection. Okay.
after inspection, whatever defect you find and note that.
Okay. Okay. Based on the sampling strategy.
Yeah. Based on sampling, what he's telling you.
Okay. Got it, sir. It's very clear, actually.
Clear?
Very
Good.
clear.
Very simple technique and very useful technique. See?
Yeah. We can also use this for our day-to-day work.
Yeah. Very much
Okay.
for audit purpose and all that you can use
Because
that.
at the moment, what we are doing is we are having
10%, 5% like that.
Yeah. If it is sample size is more than 100,000, then we say 0.1%.
That is a very
Lower the batch size, higher is the sampling.
there's a very wrong way of going about it. See?
Yeah. So now we will use this table and streamline our activity.
Yes. Always do that.
Yeah.
Okay. Shall we move on?
Yes, sir.
Yes. So, allowing up to, now, this is one observation you should make, single sampling plan, allowing up to 10 defectives does not, out of 500, does not mean that we are accepting 2% defectives, you see. Similarly, no defective out of 500 does not imply that the lot will be defect free. The sampling plan N equal to 500, A equal to 10 ensures that on the average, we will accept 1% defective as per AQL agreement. Okay. So that is what it's talking about. Okay. Now let's go to other levels of inspection. Now compare the sample size later. Now, if you go to title level, what is the SSL? If you go to title level, for the same example, 1,47,000, AQL 1%. What is the title level? SSL? Just see, as you saw N, similarly
Yeah.
for title level, level 3. What is the SSL?
3 means there is sample number 3, three samples.
No. Level
No.
3, level 3, title level. What is SSL? From that ST2.
From which table should ST 3 or ST4?
No, no, ST2.
ST2, okay.
Sample size folded up.
Cumulative position table, ST2, okay.
Yeah, 1 lakh, what is the SSL there? For Titan level,
तो कौन सा table देखना है sir? Because
ST2.
ST2 में बहुत सारे हैं sir.
ST3, yes, sorry, ST3.
हाँ ST3 ना वही.
Yeah.
हाँ,
1 lakh.
ST 1
Three
lakh.
may
What is
found out N for normal level. For Titan level, how much?
Titan level is P.
P. You see, it is written here, P.
P.
For
So P is 800.
Right, 800, and what is the acceptance number?
Which one should we see?
1%
800.
equivalent, 1% equivalent.
1% is 14.
Right, this is what is written here. You see?
Yeah.
Clear? All of you are clear, na?
Yes, sir. Clear.
You see now here it was 800, 500 to be inspected. Here it is 800.
Yeah.
Excuse me, sir.
Yeah,
Yes,
please.
sir.
I have one query. The
Please.
single sampling AQL plants the chart what you have told, right?
Yeah.
In that, actually, what is the acceptable quality levels AQL percentage? It has
1%.
been mentioned.
1%.
1%.
Yes.
This you have to decide along with your customers or based on your process capability. Okay. Very good question.
Okay.
This you have to find out on your own.
You have to define acceptance criteria for that.
Yeah.
Okay.
No, there is criteria. For example, in our all leakages, for example, on our
Yes.
metal box, we used to have 0.25% of it. For
So, excuse me, sir. It
Yeah.
is the percentage of rejection?
no percentage of defectives. Percentage of
Defective.
defectives.
How much are you going to accept and reject here?
So you divide normally what we I'll tell you, doctor, what we do.
Yeah.
Normally we divide the defects into critical, that is functional, major and minor. For
Yes.
critical, we have the practically 0.1%
Right.
AQL. For major, we give 0.25 or 0.5. For minor,
Okay.
you give 1%. Like that we do.
Right. Okay. See.
Critical, major, minor, we decide.
So here it is defined as 1%. So we look at 1% and 800 and then it comes to 14.
Right. Now go to reduced level, level 1. What is SSL?
Is L.
L. What is sample size?
L is 200.
Right. What is acceptance number?
At 1%, it is 5.
Right. It is written here, you see.
Yeah, correct.
Now you see 1:2.5. I was telling you, na? It was 200 is numbers here. Normal level is 500, that 2.5 quantity, double 2.5 times of normal. And 800 here. You see.
Find it is 10 actually, 10.
Yeah. So therefore, this is how your number keeps on increasing. See.
Okay.
Now go to specially reduced levels. S4.
S4 is for the same lot is J.
J, correct. For J, what is the sample size?
80 is a sample size.
Right. And what is the acceptance number?
And 1% is 2.
2. Right. What is written here? You see
Yes.
this table written here.
Yeah.
Now go to S3.
3, yes.
What is SSL?
G
50.
and sample is 32. Sample is 32.
But then problem. What is telling you? What is the acceptance number?
Here it is not 32. It is not there. It is saying go to 50.
Yeah, right. There you go to you go
50.
to H. G,
Yeah.
you strike it out because it is
Yeah.
not able to decide. You
Yeah.
have to go to H, that is
That is 1.
H.
It is 1. 1.
right. H, that is equal to 1. Understood?
Yes, sir. Very much.
Right. Now go to next level, S2. What is sample size letter?
S2 is
13.
E.
Sample size 13.
13.
What is some SSL? SSL is what?
SSL
E.
is
E for England. E for England.
for
E.
England.
Right. And
And 13 is a sample size.
okay. And acceptance number?
Acceptance number is not is 1. No, it is not
Zero,
1.
zero.
Actually, it is not given actually because it
Mhm.
is 0, 0, 0,
0, 0.
0, 0.
So now, okay. And then S1,
S1 is D,
D. And what is the
D.
8, 8.
8? But is it able to decide?
No.
No.
He is
It
asking
is
us
saying
to go
it
to.
is B, 0. It is saying go to 0.
No, then go to which one? E.
E,
Yeah,
which is
E.
13. E
E,
zero, zero.
E and number probably 13.
13,
For E it
yes.
is 13, na?
Zero, zero,
13 and 0.
zero, yes.
So now you see how it goes. If your process is homogeneous,
Yes.
process you are able to improve your process capability, you can manage the same lot with as low as sample size of 30, but
Okay.
as high as 800. So increasing number of inspectors is not the right way of improving quality. You
Okay.
have to improve your process capability. You study your process. When you talk about on that level, paper 4 will talk about how to do that. You know, in today's context, what Japanese people do and all that. I'll talk to you on that day next week. I mean, now you see how you have to improve the process to improve your this one. As per directions provided is for
Their limit.
Rama, please mute your mic. Rama, please mute your mic.
Okay, now we shall go to double sampling plan. All of you are clear of single sampling now?
Yes, sir.
At all levels, you are able to
Yes.
manage?
Yeah, sure.
Right. Now let's go to double sampling plan, particularly let us take normal level of inspection. Okay. Normal level of inspection, double sampling plan. Okay. Exercise on double sampling plan. Find a DSP, double sampling plan, for n equal to 1,47,000, AQL 1%, and normal level of inspection. Okay.
Okay.
That's the question. Answer is from ST3, we have already seen SSL is then. Now from double sampling AQL plan, go to ST5. Now go to ST5.
Yes.
Go to ST5.
Yes.
We get the double sample, first sample, second sample. What is the first sample with N?
First sample with N
N,
is 315.
right. What is the second sample?
315.
Okay, therefore, what is the cumulative sample size? 315 and 630.
630.
Right. Now go for acceptance number and rejection number. For first
At
sample,
at what 1%?
5.
first sample, how much? Acceptance and rejection number?
5.
Is 5.
5 and rejection number?
Is 9.
Second, it is
9. And second one? 630,
12 and 13.
12 and 30.
reduction number 30.
All of you got that?
Yes, sir.
रिजेक्शन लेवल कमी हो सकते हैं
Can we now start interpreting?
कौन सा फॉर्मूला
You
Yes.
mute your all your this one and start listening, because this is important. From a lot of 1,47,000, you first take a sample of size 315, inspect them. If the number of defectives are 0, 1, 2, 3, 4, up to 5, accept the lot. If the number of defectives are 9 and above, straight away reject the lot. You need not go to second sample. On the other hand, if the number of defectives are 6 or 7 or 8, between these two, draw a second sample of size 350. If in the combined sample size of 630, the number of defectives are less than or equal to 12, accept the lot, greater than or equal to 13, they reject the lot. That means in the first sample of 6, second sample you can allow up to 6. If the first sample has 7, second sample you can allow up to 5. If the first sample has 8, you can allow up to 4. If the first sample has 9, you can allow up to? No, you can't go for second sample with sample itself. Are you now understanding what it is? Can some of you interpret
Yeah.
this table? Yeah, go ahead.
Yeah.
Doctor, interpret this table.
Should I do or allow others to do?
Whoever wants to do. If
I can always interpret this, no problem.
Okay, let somebody else do. Rima, can you do it for me? Before I ask Kavita or Dr. Subramaniam to do. Because you should also pass the exam, na? It's not that these two will pass and then I want every one of you.
मेरा भी सच नहीं है सर, because बहुत tough है ये.
नहीं, ऐसा नहीं.
अभी आ रहे समझ में, but exam will be blank.
नहीं, I am confident both the doctors will get through. Yeah, Rima, are you talking?
Hello?
Yes, Rima, go ahead. Go ahead, interpret this table for me.
What is the question?
Sample size of for determine.
ये ट्रेन होना चाहिए.
Go
अभी
ahead.
नहीं रेमा साहब क्या पूछ रहे हैं अभी ये जो टेबल तुम्हारे सामने जो है ना
Hello,
इसको
Yeah.
तुमको क्या समझा वो इंटरप्रेट करना है.
Yeah,
एक minute. Hello,
yeah, go ahead. I'm listening.
clear नहीं हो रहा. क्या है? Hello,
Yeah, I'm listening. Go ahead.
interpret हो रहा है. No, actually it is not audible.
नहीं रमा can you hear me? Can you hear me? Hello Rama. Hello
Yeah, I think
Rama can you hear me?
nothing there is a problem. You go ahead, doctor. Interpret.
Okay, so
Yeah.
this table that is in
Yes,
front of us,
interpreting.
it shows about how double sampling plan must be done. So here, as with earlier, the sample size is 1,47,000 and EQL is given at 1%,
7,000. Yes.
normal level of inspection. Now we have to go to this
And
Yes.
lot
table
sample size is
53.
1,40,000. Lot size is 1,47,000.
Yeah, lot size is 1,47,000 with AQL 1%, normal level inspection. So we have to go to table ST3 and then we saw that it was N. Now go to double sampling table ST5 where we find it is equivalent to lot first lot is 315 and
Yeah.
cumulative is
First
315.
sample size. First sample
The
is
sample size, yeah. And now if in the table it is given acceptance is 5, which means if it is 1, 2, 3 and 4 you can accept it.
no. 0, 1, 2,
0,
3,
1, 2
4,
and
5.
4, 5 you can accept it,
Including
Yeah.
5. You accept it
only
all.
5. And
Yeah.
if it is more than that, then it has to be rejected.
No.
because
It is 9 and above.
It is 9 and
Nine
above
above.
to reject it. It is rejected.
Yes.
And then in the second lot, then you have to go to the second lot.
No. Second
Yeah.
lot is same. If
That
the
is
number of defectives in the first sample is between 5 and 9, that
5
is
and 9.
6 or 7 or 8,
Then you have to go for cumulative.
then you go for second sample.
Cumulative. Second sample cumulative 630.
Yes.
And their acceptance is 12. So which
It is
means
12.
that is 6, that is up to 12, 6, 7, 8, 9, 10, 11, up to 12 you can accept, and more than 12 you should not
12
accept. 13 and
accept, yes.
above, is above should be rejected.
No. There is a little confusion. In
Yeah.
the first sample, if the number of defectives is of 0, 1, 2, 3, 4, 5, you
Yes,
straight away
accept.
accept the law.
Yes.
If it is 9 and above, 9, 10, 11, 9 and above, you straight away reject the law.
Okay.
If the number of defectives in the first sample is 6 or 7 or 8, you
Yeah.
draw a fresh sample of size 315.
Okay, right.
Now in the cumulative sample size of 630, if
Yeah.
the number of defectives is less than or equal to 12, you accept the lot.
Accept
Greater than or
it.
equal to 13, you reject the
Okay.
lot. That
Right,
means
you got it. Yes, sir.
in the
Yes.
first
Okay.
sample of 6, you can allow up to 6.
Yes.
The first sample of 7 defectives, you can allow up to 5 defectives. 5
Yes.
number of defectives. If the
Correct.
first sample of 8, you can allow up to 4. That's all.
Yes.
Okay.
Yes. Okay. Yes, sir.
So is it clear now? That
Yes,
should be
sir.
the interpretation of this table. Okay.
Okay. Take
This
it.
is double sampling plan, and you should be able to operate very confidently this plan now. Okay.
Okay.
Shall
Yes.
we move on?
Yes.
Okay. You say from the lot of 1 lakh, can you read out? Some of you can read out for me.
Yeah. From the lot of 1,47,000 items, draw a sample of size 315 first. Inspect them for all attribute defects. If the number of defects is up to 5, straight away accept the lot. That is, you need not take a second sample. Similarly, if the number of defectives is 9 and above, straight away reject the lot. On the other hand, if the number of defectives is between 5 and 9, that is either 6 or 7 or 8, then draw a fresh sample of size 315 again and inspect them. If in the combined sample size of 630, the total of defectives is up to 12, accept the lot. Otherwise, reject the lot.
Clear? All of you are clear or not?
Yes, sir. Clear.
All of you are clear? Okay.
Yes, sir. This is actually the interpretation for the previous one, the
Yeah, yeah.
table.
So read out this also. Continue.
Okay. Thus, if the first sample has 6 defectives, For acceptance of the lot, up to 6 defectives can be allowed in the second sample. In
Right.
the first sample, if the first sample has 7 defectives, for the lot's acceptance, up to 5 defectives can be allowed in the second sample. Finally, if 8 defectives are found in the first sample, then up to 3 defectives can be allowed in the second sample for the lot to be accepted.
Here?
Yeah.
Okay, good. Now, let us see what are the advantages of double sampling over single sampling. Can you read out, Doc?
Yeah. There are 2 advantages of double sampling over single sampling.
Yes.
First, technical advantage. The average sample size or average number of inspection, AOI,
Average amount of inspection.
yeah,
AOI,
average amount of inspection,
yes.
0.9x
Because
2 into 315 plus
90% of the cases you'll be accepting in the first sample itself.
Yeah.
10% of the cases will be going up to the
Yeah.
630.
up to the average cumulative.
Yes.
So is equal to 347 approximately against a constant sample size 500 for corresponding single sampling plan.
Have you seen that advantage?
Yeah, yes.
Yes. Okay.
This happens because if the lot quality is either really good or actually bad, we will be able to decide its acceptance or otherwise based on first sample itself. Experience shows that about 90% of the cases, decision is reached at the first sample. Hence, the multiplier 0.9 is used on 315 while calculating amount of inspection. Yeah. Second advantage is a psychological one. Double
Yes.
sampling plan allows you for a joint inspection of a fresh sample with concerned supplier.
Okay. He has come for a long distance, for example. You
Yeah.
give him a cup of tea and this one and all that, then said, okay, friend, I have rejected your lot, but then let us go to the stores and we'll have a second sample, joint inspection, so
Right,
that
okay.
you, so that he is also convinced that you are not doing any
Right.
injustice to him and you are quite a fair sort of buyer and all that. Okay. So, it's a
So
psychological
DSP offers more flexibility over SSP. That's what.
right. Okay. Have you understood now the
Yes,
power
sir.
of sampling? What we talked about in the morning, that how many to sample and how to sample and all that. So therefore, that has to be there on that. Okay.
Okay.
So clear?
Yes, sir.
Okay. And now 5:30 will go for review. So
Yes.
you are noting down all your points, no? Whatever you have noted on this.
Yes, sir.
Okay, good. Now let's go into tomorrow's sort of this one. Next 20 minutes, I'll talk about what we are going to do tomorrow.
Okay.
So statistical distributions are basically 2 types, you see. Discrete or attribute quality difference. And in that, we'll be talking about binomial, Poisson, and hypergeometry. Basically binomial and Poisson. Continuous for measurable quality characteristics, which we have talked quite a lot about normal, and that is sufficient for you. Negative exponential, students T, chi-square, and variance ratio will not talk. So normal I have talked to you. Tomorrow morning, we shall be spending time with binomial and Poisson distribution straight. Okay. And therefore, and their applications. So this is what we shall do tomorrow early morning at meet. Now, okay, we'll get some idea of binomial distribution. Can some of you read for me? Not doctor, somebody else should read, because doctor, I'm using too much of this one.
Yes, sir. Yes, sir. Anytime, sir. No problem. Absolutely no issues, sir.
Okay, go ahead then.
Binomial distribution. 4
Yes.
conditions of validity of a binomial distribution are binary classification. For example, defective, non-defective, present, absent, male, female, utilized, non-utilized, user of the brand, non-user of the brand, efficient, inefficient, etc.
Okay, have you
Sample size.
understood that? Is
Yeah.
it utilization, not that underutilization? If there are
Yes.
3 classifications, this will be tertiary, not a binomial. You know,
Binomial,
binomial
okay.
2 classifications, male
Okay.
or female. You are omiting the third sex. Okay.
Right.
So like that, you have to have that. Present or absent is not that eventually we has taken and got it. So
Right.
it should be a binomial matlab, it should be a binary classification.
Okay. So 2 attributes are taken at a particular time for comparison.
Yes.
Okay. Sample size n is known and is finite.
Finite. Okay.
None of
Yes.
Chance of success or failure remains same from one trial to another, and finally trials are independent.
Yeah. Now you see, chance of success or failure. That is the success of a thief is the failure of the police. Anyway, success or failure. Say machine utilization or study. You don't take utilization of machine on the managing director is taken around. Then everybody is listening to be working. You see, you don't study the utilization. This one absenteeism by telling that if you come every day in this way, all of you are going to get a gold watch. You don't introduce any particular assignable cause for that, you know. As normally it happens, then you go ahead. So these are the 4 conditions of validity. Binary classification, sample size known, chance of success or failure P remains same, and trials are independent. You don't choose a bunch of your chamchas and try to introduce some concept, okay? Because it will not be valid to all the sort of things and all that, okay? So that is what is important for binomial distribution. For that, denoting, go ahead, denoting. Go ahead, Doc.
Yeah, denoting the number of products inspected for attribute defects as N and the proportion of defectives as P, the chance of getting R defectives is given by PR
Yeah,
is
probability.
probably X is equal to R is equal to, how do we read this, sir?
NCR,
raised to-
NCR
yeah.
Q to the power R, Q to the power N minus R. The R is
Okay.
running from 0 to 1, where Q is equal to 1 minus P. Is the
So we-
proportion of good items. You know, R is, P is proportion of defective, and 1 minus P is the defective of good items, and the proportion of good items. The
This
average
maybe
of
this we may need more explanation because ye
Yeah,
thoda
I
humko some,
I think tomorrow morning we'll do that.
yeah, some examples will help us, sir.
Yeah, sure, we'll do that.
Yeah.
The average is NP and the variance is NPQ. We'll do that tomorrow, but conditions of
Okay.
validity you must know. Okay.
Yeah.
Where it is applicable, rejection, rework, downtime, utilization, absenteeism, market share, and all are governed by this binomial distribution. Okay.
Right.
Let us go to another distribution.
So, sir, here
Yeah.
the title PROB, just can
Yeah.
you just go to the previous slide? PROB DBN is binomial
probability.
distribution.
Tomorrow morning, we'll introduce the concept of probability, which will be clear now.
Okay.
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 So
Okay, sir.
today, let us not
Bombard with more of information.
yeah, more of this one. Otherwise, it will be indigestion.
Yes, sir, exactly. You know, we have started getting the gases.
Yeah, probability will introduce tomorrow morning. Then you can go ahead. Now, binomial is 4 conditions of validity. Read out which you have done. Right, Doc?
4 conditions of validity of a binomial distribution are binary classification, for example, defective, non-defective, present, absent, male, female, utilized, non-utilized, user of the brand, non-user of the brand, efficient, inefficient, etc.
We have done that.
Yeah, we have read this, sir. You read this.
Yeah, it's done. Okay, good. Okay, we'll do that tomorrow. Yeah, Poisson distributions. Condition of validity. Can you read out, Doc?
Yes, sir. Poisson distribution. Here, conditions of validity are when there is a large area of opportunity for the event to occur, but the chance of its actual happening is very, very small, we get a Poisson pattern.
Right.
Stockouts, breakdowns, accidents, customer complaints, defects like blowholes in castings, bubbles in glass tumbler, pinholes in tin plate, black spots in capsules, etc. Follow this pattern.
Okay, so clear?
Yeah.
So
Yeah.
in the large area of opportunity for the event to occur, the chance of its actual happening is very, very
Yeah. Correct, sir. Correct.
You get this.
Yeah. Like an aircraft, crashing basically.
Right. Okay, so we shall come back again on. Okay, sorry. We'll do that exercise on this. Now let us see what else we can do for today. Tomorrow again, another technique we shall learn is correlation and regression analysis. Namely,
Okay.
any technique you learned, my dear friends, you always question, why should I learn that? We have got so much to do. Why should I learn? That is the necessity of it. Like in acceptance sampling plan, we found out the necessity. Then we go for how, that is the methodology. How do you go about it? And then know why you find, and then you find where. For senior people like you, we find out where, that is, we have got so many things to do. Where are the application situations? And then if you are convinced that the necessity is there and there are tremendous application potential, go for the methodology. How do we go about it? Okay. So this is how correlation and regression analysis is one. So first, let us find out what are the necessity. Yes, Doc, roll it out. Why that is the necessity?
Yeah. Correlation and regression analysis. Why that is a necessity? Forecasting within a range.
Okay.
Replacing,
Forecasting is one technique within a range it's used.
Yeah.
Yes.
Replacing costly, time-consuming, and destructive tests by simple yet effective ones. Example, spectrographic analysis for determining chemical composition of castings rather than volumetric method.
You know, volumetric method takes 4-5 hours. Or initially, when the castings are going on, you have to do minute to minute, hour to hour. This one that can
Yeah.
be done with the spectrographic analysis. Okay.
Yeah.
Yes.
Process control, like controlling a rough grinding diameter for ultimate control of finished grinding diameter.
Right. Next.
How that is the methodology. Methodology consists of half a dozen steps. Step 1, identify the independent X and dependent Y variables.
Yes.
Step 2, collect n sets of data, that is Xi, Yi, and plot a scatter diagram. The scatter diagram itself will have a qualitative indication about the nature of relationship between X and Y.
Yes.
Step 3, quantify the nature of relationship. The
Yes.
linear regression equation of Y on X axis is given in this formula.
Okay. So anyway, formula, you need not worry. Tomorrow we shall see that.
Yeah.
Okay. Now I'll take an example and then you, take this example. And you have, today you don't have a graph paper, but at home you try to draw this one. Today
Okay.
you draw it in a simple piece of paper, what you have got.
Yeah.
Now, first you find out which is the dependent variable, Y, and which is the independent variable. For example, petrol consumption and mileage run. Which is the independent variable? Which is the independent variable? Petrol consumption and mileage run.
Petrol consumption and mileage run. Independent variable.
Which is independent?
Independent means, actually, what does it mean? I mean, it is not.
Independent means, which dependent is, it will depend on that independent variable.
Okay. Here, mileage is dependent on the petrol consumption and
Will
is dependent on the
depend on the
mileage.
mileage run. So mileage
Yeah.
run will be the independent variable.
Independent,
And dependent variable will be,
Petrol.
petrol consumption will be the depending on mileage run. So,
Yeah.
okay, mileage run will be X, petrol consumption will be Y. Is it clear?
Yeah.
So, impurities in pig iron and lime used. Impurities in pig iron will be the independent variable and quantity of lime used will be dependent variable.
Dependent variable. Okay.
Here, distance in kilometer and delivery time in days, which will be
Yeah.
independent variable.
The delivery is dependent on the distance.
Right. So x-axis you take
Yeah.
the delivery time and
Yeah.
y-axis you take the distance you take the x-axis. Okay,
Yeah.
that is independent variable. Na?
Yes, sir.
Delivery time will depend on this. So
Yeah.
y is your delivery time and x is your distance in kilometer.
Distance in kilometers, yes.
X-axis you take the delivery time and
Yeah.
y-axis you take the
Yeah.
x-axis you take distance in kilometers and
X is
y-axis.
distance and is the delivery time by.
So can you plot that? Can you plot
Yes,
that
sir.
from this data, please?
Yeah.
Great. And night you plot in a nice graph paper and show me.
Graph Okay.
Now with your simple paper you have got, you choose the scale accordingly and plot that. Let us see. With that we'll close and then go for summing up. With the scatter diagram, we'll close this today's session
Yes, sir.
and we'll start summing.
So now you should plot a scatter diagram. Okay.
Plot a scatter diagram.
So here the range will be minimum 325. So I will take from No, 200 to 1,300.
You decide.
Because lower is 200, 215. So 200 I'm taking, and higher as 1,000, no, 1,400, because 1,350 is there. 825, 200, 300, 400, 500, 600, 700.
Yeah.
So, 3.5, 825. Two 15, 1. 10704. Leave 1350, 4.5. 327. 3. 155.
Ready?
Uh,
All the headings and all that you should give properly.
Yeah. Sir, correlation between distance versus delivery time of a truck shipment made by a company.
Okay, let us see what the headings you should properly.
Yeah. And should I just switch on my video? You can just see this paper roughly.
Okay,
Because I'm on mobile. So can you just come out of the video? So I will open my video.
I'll come out of the, now this is how it will look like.
Yeah.
Now, scatter diagram on delivery time Y on tracking distance X.
Yes.
You write it x-axis distance in kilometers,
Yeah, that's it. And y-axis the delivery time.
delivery time in days.
Yes, sir.
It is showing like this, scatter diagram is
Yes,
showing like this.
Yes, 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 sir. You want to
So
have it?
this shows a linear relationship is evident, you know. This is how it will look like. Tomorrow you show me the graph paper.
ये वाला x लिया, ऊपर वाला y लिया. अब सही बोल रहे हैं.
X-axis you take the distance in kilometers. Y-axis you take the delivery time in days. There
Sir,
you can,
here, what I've done is I have joined the dots. You should not
no,
join.
no,
is it?
no, don't join, don't join.
Okay, I have actually joined. I put a line between the dots actually.
No, don't join. We have to find out a regression equation, which will be the best fit, you know.
Right,
We'll
right.
do that tomorrow.
Yes.
Okay? This is how it will look like.
By same Miller, but I have only put the joined the dots, which I will not
No,
do it.
no, don't join. You remove
Yeah,
them. Don't, and
Okay.
tomorrow morning, you show me this one by one. Each one of you should show.
Yes.
Now, shall we give you the homework first and then go for summary, or have summary first and then give the homework, whichever you like.
Whichever, sir. अभी तो आपने already homework दे दिया sir 3-4.
Okay, now take the homework then first. Please read the chapter. 3 chapters you have to read tonight. One is chapter 10, process control charts. Write down. Chapter 10 of that my book.
Chapter
And
10.
every one of- Chapter 10, process control charts. Chapter 19, set theory and theory of probability.
Chapter 19, set
One
theory.
line. Set theory and theory of probability.
Okay.
And finally, chapter 22, process capability analysis. Chapter 22, process capability analysis. These 3 things we will start with tomorrow morning. Then afternoon, we will complete the regression and design of experiments. Okay? This is how
Okay.
the plan is tomorrow. Okay?
Yes,
Now,
sir.
I need, there are 8 participants as I see now. One has already left. So start summarizing. What have you, did you gain anything for the whole day we are struggling? Did you gain anything or just it was a waste of days, time? What did you
Yeah,
gain?
Not at all, sir. I mean, it was really very useful. New concepts we learned.
I don't
actually.
want philosophical answer. I want particularly what
Okay.
you gained for the day. Let each one of you must give me at least 2 minutes.
Yeah, actually, this total quality management, that first slide gave insight about what are the various aspects that a company should have. Like you said about vision, mission, plans, policies, objectives, targets, etc. So, which means what? That if these are in place, then there is a first step to actually venture into TQM. So that is one thing that we have. I mean, at least I have learned.
Very good.
And what are the approaches to total quality management has also been very well elucidated, so that I was able to learn.
Good.
Most importantly, the various types of systems that are in place, the tools and techniques that is available, and then grapes for people, etc. Was very useful. World class practice, like actually we would like to have more on that. I mean, about European type of activity, Japanese type, that is East
Yeah,
activity.
yeah, yeah.
So that, I mean, is there any standard for world class, or is it basically the approach by different countries that we can,
Then you approach and then you get the Deming Award, which is the highest quality award in the whole world.
Okay.
Getting Deming Award, you opt for that.
Right.
You
Okay.
know?
Yeah.
Then you go for Ramkrishna Bajaj National Quality Award, which is the
Yeah.
business excellence award, which is
Yeah.
equivalent to equivalent to Malcolm Baldrige Quality Award of the National
Okay.
Quality of the USA.
Okay. Right.
Yeah.
We for tissue culture we got Rajiv Gandhi National Quality Award about 8 years back. Yeah.
Great.
We went to Delhi and we got the award because we give
good.
those plants to farmers. So we drafted the application and they came for on-site inspection actually.
I know.
Yeah.
They are. I think MDS switchgear also was there, na?
Yeah. Yes.
They also participated.
Yeah.
You got it.
Yeah, I went to Delhi with the 2 of my senior colleagues and we received the award.
Good. I remember.
Yeah, and then the exercise on satisfaction indices and percentage satisfaction, that
Okay,
actually changed our mind and thought process. So we were able to actually really, I mean, though in the first instance we didn't understand the question much, but you gave some small clue and we were able to sort of, get that through. And then most importantly, your Coca-Cola bottling brand Nissamabad, uska exercise was very useful, sir, especially how to do the styling. And then how do we consider, this mode, median, and that actually we need to sort of do some homework at, the night.
Yeah, please do that.
Yeah, you will, otherwise it's difficult because it's
Okay,
slightly
now
new to us.
leave it to others to complete. You can complete at the end again. If somebody else missed out something, you hand over the mic, to your colleague. Let somebody else talk.
Rema, you ask our team one by one to please, talk about their feedback, what they've learned throughout the day, please.
Yes, please.
Yeah, start with Arvind Ji, senior.
Okay, go ahead. Chaliye Arvind Ji.
Yes, sir. Actually, today was the first day of our session. Actually, we have not gone through these books till now. So today, frankly speaking, today we have opened these books. So it was quietly some difficult, but some to know the SPC, statistical process control, you have told. Some examples you have given. The component you have told, that is there are 3 components: people, tools and technique, and systems. And you have given the definition of quality.
Yes.
Then customer, internal, external, and hidden.
Customers.
Yeah, yes, sir. Yes, sir. Then quality characteristics, measurable, non-measurable. Then variations to inevitability.
Yes.
Then variance, standard deviations. Then accuracy and precision, you have given example. Then sampling plan. Then you have given the limits, that is acceptable quality limit level and rejection quality level.
Rejectable
LTPD,
quality level.
Yeah, rejectable quality level.
Yes.
Then operation curve. Then LTPD, low tolerance percent defect.
% effective.
Then sampling plan, single sampling, double sampling, binomial distribution. So
Very good. Okay, you pass on down next to the next person. Yeah, next person.
okay, thank you, sir.
Whatever he has missed out, you can add. But so
Yeah, Rema will continue, sir.
okay. Okay, Remaji, continue.
Actually, sir, first day section was, first of all, it was very, means
Tough.
informative. And it was tough for us because as Arvind sir has told, we have not even opened the book, frankly speaking.
Now you will have
So-
confidence in opening the book.
Yes. So after today's section, it has, means we felt it is very literally interesting, and we will definitely go through the books. And today, whatever the section it has been gone, we will go through that and go to the exam.
Very good.
And the section it is like total quality management, the definition, the components, as well as what exactly the quality it is. So we have learned today itself, and cost of quality and the customer satisfaction, how it is, and what kind of customers we will be having, how it has to be, the customers' requirements, what it is, and then developing customers' satisfaction and how the dissatisfaction of the customers. These and all, it was like improvement. It was for today, from today's class. And the second, it is the statistical portion, the sampling pattern, and the diagrams, and how the sampling data it will be, statistical tables, sampling and estimation processes, and how we will do the sampling. Because earlier we were doing the sampling, it is like we have made a standard, but from today's section we came to know that what means, how the sampling exactly it has to be done in our day-to-day processes. So we will continue that.
Very good.
Yes. So, and the homework, actually we expect that it can be done it from today's class, because scattered diagram and all in school days we have learned, but after so a long time today we have done this graph.
Good. Okay, next.
I hope to.
Okay, next. Go ahead, next.
सर हमारा जो है बैकग्राउंड में बायोलॉजी है कि आज हमारा बेसिक कंसेप्ट क्लियर हो गया है।
क्या हो गया?
हमने कभी, हेलो,
हाँ जी, बताइए।
हाँ, पोस्ट ग्रेजुएशन में था हमें।
हाँ जी।
लेकिन अभी आपने जो अच्छी तरह से समझाया,
हाँ जी।
हमारे concept हैं, और हम होमवर्क और जो कुछ भी है
यस सतीश,
हम
या
ट्राई करेंगे।
ट्राई करो, और हिंदी में कल थोड़ा बात करेगा।
हाँ सर, वो तो
ओके, समझ गया मैं।
थैंक यू सर।
मेरा हिंदी तो इतना स्ट्रॉन्ग नहीं है, लेकिन हिंदी इंग्लिश मिक्स करके इंग्लिश करके बताएगा। ओके,
हाँ हाँ,
चलो नेक्स्ट। Who is next?
सर हमको आज जो स्टैटिस्टिकल्स कुछ जैसे पैरेटो एनालिसिस है, फिशबोन डायग्राम है, उसके बाद में ग्राफ्स है, और प्रोसेस कंट्रोल का जो चार्ट वगैरह थे, बढ़िया से समझ गए, कोई प्रॉब्लम नहीं है अभी।
गुड।
और आपने जो वर्क दिया है अभी वो हम करेंगे उसके बाद में, क्योंकि बहुत सालों के बाद आफ्टर 30 इयर्स ये किताब खोला है हमने, तो हमारे लिए टफ है बहुत।
I am doing it
हम बता
after
नहीं सकते कितना टफ है, लेकिन टफ हो जा रहा है, लेकिन हम ट्राई करेंगे सर, नो प्रॉब्लम,
कोशिश
आई
करिए।
विल डू। हाँ हाँ,
आपका तो 30 years, मेरा 60 years, 61 I passed out ना।
but sir you are continuing in this subject.
Not all the
This
time.
subject is totally new for me.
Okay, good. But you will learn quite a lot, I can assure you. Which you can apply. आप apply कर सकते हैं आपको काम पे। आपका
Okay, okay.
Okay. Okay, next. Anybody else is left? Otherwise, we'll ask.
No, sir.
What is
All-
Dr.
all
Kavita? She is gone or there? Dr. Kavita Pandey? You are there or you are left?
Yeah. She is visible in the members participants list.
Okay,
But,
go ahead. Go ahead. And
Dr. Kavita, do you want to talk? You want to give your feedback?
I think she has left.
Yeah, she's there in the list, but maybe not present.
Okay, then somebody else you go ahead and we'll ask her again after she comes back.
Yeah.
Okay, go ahead.
वो तो रीड करके आना तो इतना तो वो ग्राफ का
अभी जो पढ़ा है ना मैडम, आप घर को जाके उसको पढ़िए, तभी वो सब सामने का समझ में आएगा। अभी ये जो है, ये पढ़े जो कुछ आने वाला नहीं।
हो गया
हो गया, बंद हो गया क्या?
बंद कर दो।
नहीं वो वापस करके वो
नहीं, कुछ नहीं होने वाला, छोड़ दीजिए। हो गया ना? कल बोला ना उन्होंने।
हेलो
Yeah, please. Kavita, you are there?
no sir actually she's
Huh? Dr. Kavita is there. You have reached a chat. We would like to consider sampling plan of 100,000. So how to go about? What is that? What does that mean? What do you want to please clarify? What do you want? AQL level or reduce sampling and all that? What do you want to know, Kavita? This you have introduced in the chat, but let's not worry. Okay, go ahead. Next one, go ahead. Anybody else? Anybody else is left out? और कोई बाकी है?
सर कल होमवर्क हेलो
हाँ जी, होमवर्क 3
तो
chapters.
कल tomorrow which graph actually which one we have to do as a homework?
Homework 3 chapters you read first.
3 chapters we have to read. Okay. Apart from that,
10, 19 and 22. These 3 chapters you read
10
first
and
properly.
okay.
And whatever
Okay.
is done today, you revise that.
Okay, all right.
Okay. And draw
Okay.
those 3 charts. One is this scatter diagram. Second is
Okay.
histogram. And third is the
Okay.
moving average, which I gave you.
Okay, okay, fine.
These 3 charts you draw. A lot of homework, but it will be helpful to you. And tomorrow I'll tell you which chapters you should read, which chapters you can omit from that big book I have given you. Okay?
Okay, fine,
Right.
sir.
Remind me. I'll give you.
Thank you, sir. Thanks a lot, sir.
Okay, Dr. Subramaniam, summarize anything we have left
Yes,
out.
sir. Tomorrow, what time are we starting?
10 o'clock sharp.
10 o'clock. Okay. Sir.
And then, Doctor, you have left out something today's portion. You can fill the vacancy, fill the gap. Anything you have left?
Banerjee sir,
Yeah.
if possible, shall we start at 9:30 tomorrow?
Oh, no problem. I have no problem.
Because today we started late, and
Oh my God, quite a lot late.
And tomorrow people may like to get released early.
But they are working from their home or something, na?
Yeah, but to cover that half an hour probably or 1 hour today what we lost, if we can start at 9:30.
I am okay. I am with that.
Is everyone okay with 9:30?
Moving table.
Yeah.
कल Sunday है sir.
Moving ना ये जो कितना जो आ गया है उसमें से एक रिमूव करके मूविंग टेबल.
संतोष सर.
Yes, sir. Yeah.
10 बजे ठीक रहेगा.
अच्छा. Okay.
10 o'clock. But 10 o'clock sharp,
Okay.
not like today.
Okay.
Not like today. Huh?
Sharp.
नहीं,
We
नहीं,
should
कल
start
हम
for 9:45 से लॉगिन चालू कर दीजिए so that 10 o'clock we start, right?
ओके. तो आप लिंक भेजेंगे ना कल के लिए?
हाँ?
लिंक आप भेजेंगे ना कल के लिए?
हाँ, लिंक मैं आपको भेजूंगा आज. Tonight I will send. Also,
Okay.
I will send you some sample MCQs for objective section and application section.
Okay,
which, I will email to all of you and Mr. Banerjee. So,
Okay.
some discussion around that, can be taken.
okay. Chalega, sir. No issues. No problem.
Because the examination pattern has changed, so we want to
Okay.
tell you something about the new exam pattern.
Chalega, sir. Chalega, no problem.
Right.
Also, we
At 10
need
o'clock
dates.
sharp, we should start.
Yes, sir. Also, we need dates for the other 3 contact classes.
I have emailed you the schedule.
Okay.
So please check your email.
और कब आज की है क्या सर?
आज मैंने भेजा है, मैंने around 1 o'clock I sent, after
ठीक है, मैं
you
देखता
talk.
हूँ. Okay, सर मैं
आज भी
देखता हूँ.
भेजा है सर, there it may be in spam.
स्पैम में क्यों जा रहा है, I can't understand. So,
मैंने 2 बार मार्क किया, नॉट स्पैम मार्क किया, मैंने 2 बार मार्क किया, नॉट स्पैम.
Okay, you note down now. If you are not, tomorrow we are continuing with SPC. Okay.
Yes, sir.
Next Saturday, coming Saturday, we are doing Friday. Next coming Friday, we are doing the contact session on paper 3. Santosh Kadagadi will do Friday, May 27th.
Okay.
Okay. Then Saturday, May 28th, I will do paper 1. Saturday, 28th May, I will do paper 1.
Okay.
Sunday, May 29th, I will do paper 4.
Okay.
Bas, that is the sort of thing. So,
Okay.
all
Thank
the-
you, sir.
okay. Examination, examination you want to know?
वो तो जून में ना सर वो?
June,
June,
Yes.
May.
end
Eight-
June, end of June.
18 June is for paper 1. Saturday, 18 June. Sunday,
Okay.
19 June is paper 2.
Okay.
Then Saturday, 25th June is paper 3.
Okay.
Sunday, 26th June is paper 4.
Okay. Sir, Abhi, what I had mailed to NCQM is that
Yeah.
I will be appearing for paper 3 in June.
That you write down, whatever you want to appear. That you need not appear.
नहीं वो उनको मेल कर दी मैंने. Only one
Yeah,
paper I'm appearing.
Yeah,
and then,
that you deal with the office,
Okay.
Yeah.
ठीक है.
Yeah, yeah.
Okay.
Okay?
Okay, sir.
Okay, we'll stop here today then. Thank you very much for your
Okay.
patient hearing.
Thank you, sir. Thank you very much.
Some people are trying to smile, shows things have not gone that bad. So I think we'll take it up tomorrow with refreshed mind and go ahead with that. Okay?
Sure. I hope. Thank you.
Okay, thank you, sir.
Thank you,
Bye.
sir. Thank you.